Welcome, everyone. Thanks for coming out tonight. My name is Doug Sartori. I am the person who organizes this interest group. You have joined a border city data talk for Windsor Hackforge. And tonight we have a really exciting presentation from Ken Hudak, who's going to talk to you about Python basics and working with Jupyter Notebooks. So I'm really looking forward to the talk, and I won't take up too much more of your time. Just a little bit of context about Ken. Ken has extensive experience managing data programs for government agencies, both in Michigan and here in Ontario. He's also a part-time instructor in St. Clair College's Data Analytics for Business program. He definitely knows his stuff, and I'm going to shut up and get out of the way and take it away, Ken.
Fantastic. Thanks, Doug. Now that I have the expectation of being very exciting, hopefully we can meet that expectation. So it's great to be here and doing a presentation and a talk with Hackforge. Actually, one of the very first things that I did when I moved to Windsor was had the ability to attend a intro to SQL talk with Doug, and I was really impressed with his talk there and the organization itself. So it's good to be here and to be able to share some introduction to Python with everybody here. So I appreciate you taking the time to attend. So I'll go ahead and share my screen. Okay. So first of all, I just wanted to give a brief overview of Python itself. And this is going to focus more on approaching this programming language in a way that you can manage it easily on your own PC, and also have it set up so that you can be able to share your results and your work with other people within your workplace, especially in academia. This is a couple of good ways to kind of work with the programming language. And the key aspect of that is by using Jupyter Notebooks, which are going to be an interactive notebook that you can compile your code in and do most of your work. And probably the best way to get started with Jupyter Notebooks in Python is by going through something called Anaconda Navigator. And Anaconda Navigator is a GUI interface that will pretty much manage everything that you need to do. It will install Python for you. It will install different libraries that you'll need to use, and that will show during this talk tonight. And another thing it will do is help manage the environments that you're working in within Python. So environments can kind of be kind of different little cells where you can set up different packages depending on what you're working on. You can keep different versions of Python if you were going to do Python 2 projects or Python 3. We're currently in Python 3, but managing your environments is just a good way to keep everything, have your libraries and modules all staying the same. Sometimes these modules will update on you, and there'll be minor differences in the syntax that's used. And if you're constantly updating that, you may have to go back in and update your code. But by keeping your environment static, you can prevent that until you can get time to go through and do your updates. So this is Anaconda Navigator. You can just Google this and install their installer. And it comes with definitely a wealth of different applications that are included with it. And we have some things that you might be familiar with, like VS Code. Then there's RStudio. You have PyCharm, which is it's a basic but powerful IDE for doing your editing in Python. Spider is another Python environment. And what we're going to be using here are Jupyter Notebooks. So real quick, I'll just go in, grab one of my environments, and to just give a taste of what the terminal looks like. We'll just be here in a terminal. I can just declare that a variable named A equals 3, and a variable named B equals 7. And I'll put that in, and I'll print the results of adding A plus B and 10. So got the right answer, not the most glamorous interface. It would kind of be tough to have to go back through and retype all this every time you wanted to do all of these functions. So what Jupyter Notebook has come up with, and I will launch one here, is a way to just launch a notebook that you can work in based on a browser, just within, like I'm using Chrome browser here. And this will come up, it's gonna launch a notebook that we can do all of our different coding in. So for the first example that we're gonna look at today is just doing some basic exploratory data analysis for local Windsor election results. So when we open up the Jupyter Notebook, this is the interface that you're going to get. Just a little bit of orientation. Up here on the right, we see that we're working in a Python 3 environment. We're running Python within a kernel. And one key thing to look for is this hollow circle here. It says kernel idle. When it is processing, that's going to be filled with gray. And most of the things that we are going to do, that's going to blink on and off in an instant. Sometimes if you're doing something like machine learning with a convolutional neural network, that will just go gray for 3 or 4 hours while it does the job. So if you think something isn't happening or it's not responding like you think, you typically can look up here and see the status of your kernel. So another big feature of these notebooks are that you can make your code all in different cells, and there's 2 different types of cells. So this first one here is in Markdown language. So I can simply create like a decent header on what we're doing without having to, I can make a new cell here if I wanted to write the same Hackforge thing and it was in code. I have to do the hashtag to comment it out and make my comments here. But if I'm trying to teach this or I'm trying to share this notebook with others, it's nice to just have this package here with Markdown language. So for each cell, we can have words in Markdown. We can also come down here and go into these code ones as well. So that's an excellent feature here. And then also I can save this notebook and I can send it to someone else and they can then go ahead and do like the exact same process that I'm working on here. So like in academics, it's great to be able to have these notebooks built and then you can send them out to students. They can go through, complete the exercises in here and then submit that back in as they're turning in their assignments. So it's extremely versatile and I would recommend going this route with Jupyter if you're just getting started. So just a couple of quick things before we get into the exciting mayoral race of 2018. Python is what's called a high-level language, and it was developed particularly so that it could bring computer programming to everybody. And the writer is like Guido van Rossum. He invented this about 30 years ago. So that's our 30-year anniversary. And he was just looking for a way between like terminal script language and C. And what he came up with was Python, and he was just looking for a way to be able to program in something that was as close to English as possible, just English phrases. And Python was a result of that. So we have Guido to thank for through a lot of different industries. And currently on GitHub, Python is second in different repositories, only to JavaScript. So it's extremely popular through a bunch of different industries. So just a couple of basics. When we're working in Python, like I got a couple variable assignments here, and I want to load these into memory. So I'd like to have C equals 3 and G equals this date. So I'm going to put my cursor just in this cell, and I can go up to the toolbar and I can select run, and it will do nothing to us, or at least apparently, right? It's just going to load those variables in there. And another key aspect of Python is that you don't have to declare the type of variable that you're putting in. It's going to automatically interpret it. So that's, again, going back to a simple user function, but it's going to cost you a little bit in computational time. But for what we're doing here, you're not really going to notice it at all, and it's definitely worthwhile. So it's got some variables in here, and I can go ahead and see what the data types are for each of these by using the command type, and the parameter is going to go in these parentheses here. So I'll just put in C, and I'll hit run again, and we get integer, which is a whole number, 3, perfectly what I expected. Type of D. Instead of going up to run here, I'm going to use the keyboard shortcut of Control-Enter. I might as well say that now, because I'll start defaulting back to using the keyboard shortcuts. Okay, so float. So we got a decimal, not an integer. We got a decimal number here, which is called a float. E, we have stored in. This is going to be a string in Python. So that's a string of characters, non-numerical. You also have Boolean operators. So you can have true or false. So that responds back. So what Python is doing, it's looking at these numbers. I haven't declared any of these variables like you've seen in other languages, and it's automatically interpreting what I hopefully intend will put in there. For G, we run that. The problem here now is this is returning what I put in as a date as an integer. So in this case, in one big thing when we're doing data analytics, there's going to be a lot of time series analysis where you're looking over change over time. And it's going to be important to always ensure that our data types are correct. And there's easier ways to do it than by going through how I showed here. But one of the first things is that we can import libraries that do a lot of the work for us. They are essentially functions that someone else has written that we can take advantage of. And one of these libraries is called datetime. And it's going to take a variable that I named G, and I want to assign the datetime function to the numbers in this parameter. So December 31st of 2021. So we'll go run that and print it. And now we'll see that it's converted it into like the standard ISO time that you're used to seeing in SQL. And that's how we need to have our datetime series set up. So that's just something to keep in mind. But here with importing datetime, all we're doing is bringing that in basically one line of code, and we're doing this whole conversion. We're not having to write the whole function or do this ourselves like through coding. So it's super popular. There's thousands of different libraries for everything you can imagine. But this most basic one, I think I use in every single project to make sure that I'm getting this ISO time here. So that's the datetime library. So we will move on to what everybody is here for tonight. We'll get these election results. And so pretend you don't know what happened in 2018. And we are going to have another library help me out here to do this. And that library is called Pandas. And I've got this nice graphic in here as part of loading an image inside of a markdown cell. So just another nice thing that you can do when you're not working in the terminal is get a much better aesthetic on what you're working with here. So just like datetime, pandas, I'm going to import, which is going to load it. And then it has this as word here. And that is an alias where we're going to refer to pandas from here on out as PD. And it's just going to save you keystrokes when you're going through and doing this programming. So just import pandas, but always call it PD from now on whenever you see it. So we'll import that. Actually, this one we are getting a little bit of the kernel being busy and package to idle. So pandas is now loaded. You really don't get any results or acknowledgement that it's done. You just have to watch here. And then sometimes you'll see an hourglass in these square brackets here. So pandas works in something called data frame. And the data frame is like a tabular representation of the data. It's, I guess the easiest way to say it is it's the closest to Excel as what you would expect. And when we're working with pandas, it's a library that's going to help us import and transform and export different kinds of data. And it's also going to help us group and summarize it as well. So I'm going to declare name a variable called data frame. You can name this anything you want. So there's nothing unique about this name. You just name it Ken, whatever I want to name it. And I'm going to assign it to this pandas operation, which is going to be read CSV. So I'm looking to read a comma delimited file. So I'm calling on pandas to read CSV. And the CSV that I'm going to read is this string here. And I'm just going to take it straight from the City of Windsor open data website. So I'm going to grab that CSV. Somewhere in there, it's got a funky non-Unicode character and it'll error out. So I'm just going to have Unicode escape as an additional parameter in there just to avoid that, but it's just a workaround. So I'll Control Enter to run it. So now I have created that data frame, and the name is data frame as well. So I can look at the type again, like we saw above. Type, put in my variable name, data frame. And here we go. The results is a pandas data frame. So it's exactly what I'm looking for. So now we start getting into some powerful exploratory tools. I have no idea what happened, right? I can't see anything. I know there's something in memory and it came from this CSV. So just to get a glimpse of what I'm looking at, I can look at how many records I have. Records in pandas are rows, and attributes are columns. So we have rows and columns back to the Excel land again. So I'll see how many records and attributes I've got by using the dot shape method. Data frame. So I'm saying in data frame, what is the shape of that? And it'll come out here with this output. So I know I've got 3,057 records or rows and 6 attributes or columns. So it's just a good check on learning that something actually did load from that command that I built up there. We can look to see the different data types that Python detected by using D types. So again, on my variable called data frame, use dot notation to say D types, and it's going to put out what is detected. The only difference between regular Python and pandas is that strings are just called objects in pandas, but that's still a string. And that looks like we have a attribute called total, and it's an integer. So I would expect when we get down to that point, I should see ward, poll name, candidate name. Those are all strings and characters, so that makes sense. Total, it's going to be a count of votes most likely, and that's an integer. So those are all have already been automatically defined by Python. So we can get to looking at what this actual data looks like. And there's a couple ways to do it. Pandas has the .head method. It's just, think of it as like header, and it will have parentheses. You can leave it default with no parameters, and it's going to give you the top 5 rows that it finds. So I'll control enter here, and here it is. This is starting to come together. I'm seeing my column attributes and then my records down here. One thing to point out about Python is that it's a 0 index language. So when you're doing some math problems, when you're first starting out, or you're trying to grab the first 10 rows and you keep getting 11 or 9, don't forget that that it is a 0 index. So this is your first row is called 0. So this is why when I can explicitly put in 5. So I want the top 5 rows. It goes to 4, but just remember 0 is where it first starts out. You only make that mistake a couple times, and then you don't forget. So .head is there to see the beginning, and just the opposite of head, well, I guess would be feet, but in Python it is tail. And here's our bottom, 3056. Should match up to our shape. So we got that many. We got one header row, so 357. When you look at the 0 indexing, that adds up. So we've got some advanced polls down here at the bottom, some trustee results. So that's just a good way to just make sure that everything came in exactly as expected. You can also use just slicing instead of using the pandas function. We can go in with square brackets, and I can see row 9 through row 16. You just go here wherever I want, and it'll bring rows 9 through 16, which actually displays row 9 to 15 because of the 0 indexing. So I'm still seeing my my mayor, candidate name. Looks like Tom got just 2 votes over in Ward 1 at the Capri Pizza. So getting a little bit more glimpse of what's going on here. And the thing is, I'm not really sure how many people ran for mayor. This may be like an inclusive list. I might be able to slice this a little bigger. And it might be okay if you're local and you know what's going on. But if you did this for a national race, like, you're looking across all of Canada, you're not going to be able to pick everybody out of here. So there's a quick way to do this with a pandas method called value counts. So here I'm saying, I'm looking for mayor. So far that's all we've been seeing is mayor, and you could assume that's all that's in there. If I had 1 million rows, 2 million rows, I wouldn't be able to pick all these out. So now I'm going to tell pandas that what I want to see in my information, in my data frame, in the attribute column contest title, which is here, we have all mayors so far on the screen, go ahead and give me the value counts. And what that's going to return, it's going to count each record or each row where the word mayor is in there and get 565. But I'm showing that I've got a bunch more in here, and I'm only interested in mayor. So I was kind of blind to the fact with just this section here. I thought it was all mayor, but I've got a lot of trustee and counselor elections as well, and I'm not interested in those. So I can use pandas to just filter these out and pick the contest title based on a condition. And this time what I want to do is I want to create a new data frame. I'm going to call it DF. And that's what you'll normally see just in standards, just data frame DF. So now I'm going to create this, and DF should equal the information in the data frame and take the column called contest title and equal the string mayor. And in Python, the equivalency function is 2 equal signs when we're looking at comparing strings like this. So we'll go 2 equal signs, and I should only get mayor. Run that. We still don't see the results until we display anything. So now I'll go into my new data frame called DF, go into DF, let's slice it, just starting at record 560. So that's looking good there. Let's look at the shape again. So now we're down drastically. We only have 565 rows and the 6 columns still. So we've completely filtered down our data set down to just mayor. If I want to look at, see who the candidates are, I can make a list of each unique mayoral candidate's name. So this is helpful. Also, if you're working with big data and you have millions of records, I can just get a list of the candidates that were in here. And here we're going to call on pandas. PDs are alias for pandas. We're going to use the unique method. We're going to operate on my new data frame called DF, and I want to do that on the column called candidate name. So that's going to put out a list of the unique values of every person that is in the mayoral race. So this is helpful sometimes too, if like this, say this is computer generated, so this is pretty clean. 90% of the time, especially if you're having user entered data, it's not going to be clean. So I could have a Drew Dilkins that's missing the E, and it's going to get included as another variable because it's not unique, it's not the same. So when I have misspellings, I'm gonna have maybe one T in Matt instead. So it just gets dirty when people are entering this. But the cool thing about pandas is you're gonna be able to see these right away. And then you can kind of go back through and you can do like a find and replace and correct all of those errors, and it'll just iterate through and fix everything. So after you go back through, you fix your errors, you just run this unique function again, and this is the list that you'd be looking for. And you'd be surprised, white spaces count. Leave a white space after the S in Dilkins, it's going to be considered a totally different variable. So there's a lot of white space cleaning up, taking out. People's computers will give you those funky symbols, non-ASCII symbols. Go in there, especially people that will have accents in their names, and that always comes in different. So it's got to watch out how you're encoded. But the key is with unique, you'll see those errors and you'll be able to fix them from this point. So now I want to look at the number of votes that each one of these candidates in this list got. And this time I'm going to rename my data frame to total votes, or I'm actually creating a new one. And sometimes I'll switch and rewrite it to a new data frame, because if you do make a mistake or you accidentally delete a bunch of rows you didn't want to, you could always come back up here and PD is still holding all the information that you've got so far in memory. So it's nice to be able to just go back up and you could say, PD equals total votes and kind of reinstate that. So just by changing a little bit down here, especially with a new topic, then it just helps keeps things more orderly. And another thing we can do just to keep it structured is I will add a new cell chunk here, and I'll go up to the code, I'll change it to Markdown, and I'll put count the votes section. And you can use the hashtag to make it headers. And when I run this, I get that. So just keep it a little bit more structured. So one thing, like a huge key in SQL is the group by, and you can group by in Python as well. And what I want to do is create a new data frame, and I want to take the existing information that's in our DF data frame, and I want to group it. And what I want to group by is I want to take every single time I see Drew Dilkins, I want to just collapse them all into one. I want one line. So I'm going to have 200 of these, and I want to collapse them all. But I also want to take the number of votes that Drew got in each row, and that's in the total. And I want to sum them up. And that could end right there, but it might list them alphabetically by candidate. And what I really want to see is I want to see the person who had the most overall votes be on the top and then go down in descending order. And in Python, the way to do that is then to say that ascending is false, which is the same thing as saying descending. So we can collapse this, put everybody together, add up the sum of all their votes, and have it go from the highest on the top and the lowest on the bottom. We get the operation successfully went through because you didn't get an error. Unless you do a print or a head, you're not going to see anything. So now I can just display the variable total votes. And when I do that, I see that it took candidate name and candidate name and collapse them, flatten them, and then added up each one of the votes. So we see that Drew had 31,201 and Matt had 1866. So we are at a point where, I gotta move my zoom here. Okay, so now we've got our list. Basically, we have the answer that we were looking for. So if you haven't turned on the news in the last couple of years, you should look out the window and see that Drew Dilkins has won the election in 2018. We can also make a plot of these numbers as well. And I'm going to make a new title here. I'm going to put my cursor in and get rid of the zoom bar. Okay. Changes from code to Markdown. And I'm going to go to a title 2, and I'll say charting section. Run that with Control Enter. Now to make a chart, we are going to borrow a library from matplotlib. So if you've been in academic research, I'm sure you've used matplotlib a lot. When we talk about aliases, this is going to be a big one. If you didn't use an alias, you'd have to type in matplotlib.pyplot every single time. We're going to name this PLT, and that's going to be the industry standard as well. So pandas as PD, matplotlib.pyplot is PLT. So at this point, I'm going to take, remember, we're still working in a data frame called total votes. So I want to go total votes dot plot, and then what kind of chart is going to be bar. And then just to kind of clean it up a bit, I'm going to use PLT. The y-axis label is going to say total votes, and then PLT.title. We'll see what happens when we run this one here. Okay, so got a little Y label problem in here, but we've got our, you know what? I didn't run matplotlib. If that happens, you just forgot to import the library. It's a good example. So here is our bar chart, nice and simple. This is coming out of matplotlib. If you wanted to make something for publication or have it be a lot nicer, there's a library called Seaborn, and it just makes a lot nicer graphs. So what we've done is made this bar chart, and we can see our vote totals for the 2018 elections. So the key with this title is, like, we've got total votes on the y-axis, and that's a string. I just put the letter E in here. And if you remember, all the way back up here at the top, I've loaded this E is equal to the string of 2018 Windsor election results. So all it did, it kept it in memory that whole time. And when I said E, it just printed E, which is a string, which just says this text here. So it's easy to replicate. And now what we can do, we'll pretend that it's a different year, and I want to see the exact same results for the election in 2014. So what I'll do is comment out my 2018 CSV, and I'll go back now to Windsor's open data portal, and I'll grab the 2014 election data. Now, this time, they published it in Excel format, okay? So not the greatest way to run your open data portal, however, grateful that it's there, so thank you. But I'm gonna have to change from read CSV. I'm gonna have to ask pandas to read Excel, and you can do that. You can read SQL, you can read JSON. There's multiple things that you can read in, but luckily we've got read Excel. So here at this point, change that. So when we talk about reproducibility, it took me, let's say, like an hour or two to write this code. But now, if I want to just see what the results of 2014 are, really all I have to do is change the source. I can change E to 2014. And now I can go to cell and select run all. And now I don't have to step through all these. I can just run the whole thing. That's a disaster. So if you get an error, just when you see these errors, it's pretty big, right? So always just go to the bottom first. And now I don't know why it's not getting not supported. I do right here. I'm missing a end parenthesis. That's why I don't live code these things right now. Let's just step through on the load here. That's right here. No, that one was there. Yeah, I don't know, but I just had it working before. So I definitely have some issue in here that is that the Excel file is not supported. But it will open up Excel. So let's get back out. I'll comment this out. We'll bring this back in. So now if I just wanted to see again, I could go to cell, run all. Basically runs everything for me, and I end up with my chart here. So that's what I was going for. I just needed a chart for a report or a publication next year or whenever the next election is. If the structure of this CSV here is exactly the same, all you'd have to do is just change your string and up to point it to wherever the new election results come out, and you'd be able to just run off and you get your chart of the election results. So you have 15 minutes. The second thing I wanted to show was advancing Jupyter Notebooks past even this. So kind of like a late night telesales commercial on TV. Like, wait, there's more. What I want to do now is introduce you to Google Colaboratory. And what Colaboratory is doing is Google set up a Jupyter Notebook that is running on their Google Cloud Compute platform. So now instead of using my personal computer processing and memory, I'm actually able to conduct the same work that we just saw, but I'm doing it on Google Cloud. So you can really go into this browser in something like a Chromebook and just do all the data analytics that you need. You can run machine learning algorithms on there, and you're not going to be limited with disk space or RAM in this case. So this is a really great feature that Google has. I've brought in our traffic demonstration notebook here. I just did file and upload notebook, and it opens the same thing. You're looking for your Jupyter Notebook, which is the IPYMB, which is interactive Python notebook, and load it up in here. And instantly I'm getting, I'm connected to a Python 3 Google Compute Engine, and I'm getting 12 gigs of RAM and disk space. I think that's my Google One account, but 107 gigs of disk space is allotted to what I'm going to run here. So if I'm going to do something and run it, and it's going to run all night, a lot of times I'll run them through Colaboratory and just let their resources do all of the computational work, and then you can leave it. And actually, if it's going long, you'll get a prompt that says, do you want us to email when it's done? So it's great. You can just launch it and let it go. So this is really amazing that Google has this. And with this, you don't need to download Anaconda. You don't need to download Python. It's just nothing. You go to colab.research.google, sign in with your Google account, and you can just upload a notebook. You could take a notebook that you found on GitHub or wherever you got it and load it up on here. And 9 times out of 10, it'll work. Sometimes you have to install a couple of libraries if they're really obtuse, but this is definitely a way to go to get started. And also, you can share these, and other people can come in and work with you together. So especially in the classroom, this is really big too. So like a student submission can just be this URL they can authorize to share. And then when you get the results back in from the exercises, just go in and do this. Otherwise, you're getting Python code, you're getting notebooks. I got to open up Anaconda, load it. Sometimes I won't have the libraries that they use installed. So this is a really great way to standardize it. So with traffic, we are going to look at here on Church Road, kind of going this way here, north towards the bridge, and south away from the bridge, and we'll be sitting at the intersection of Malden Road. And once again, be using the City of Windsor's open data, except for this point, they're using their open data API, and they're using a standardization method with that that's called Swagger. And they have all of the documentation over at the city's webpage that's listed here, and that'll be in the notebook. And as of right now, the available intersections that are open on the open API are these three. So Dorchester, Totten, and Malden, all at here on Church Road. And again, here's the power, right, of the Jupyter Notebook. I can put this picture in here, and it's just super convenient to be able to teach this way and demonstrate. So I'm going to do Malden Road, and what I don't know specifically what the city has, but obviously they have cameras or some types of video scopes that are monitoring traffic here, and we can get some data out of that. And we'll say ultimately, what I'm looking for, I just want to know like how many cars came out on December 9th. In the browser, this is what the response from the API looks like. So we're going to use Python to kind of make some sense of this. It's JSON format that comes out, but let's be a little tough to tell right here on December 9th how many vehicles had passed through that intersection. So when I go, the first thing I'm going to do, I got just going through Google Colab and pulling information from a URL. I'm going to have a SSL problem. So like, don't do this at home type warning. I'm going to bypass and tell it to not check for SSL certificates, just because I'm constructing the URL. I'm confident that it's not going somewhere wayward, but just keep that in mind as a caveat that a malicious actor then could get through if I went to the wrong URL by some chance. So again, for traffic, we are going to use pandas to help us transform and look at this data in a tabular way. In this case, what I want to do is I'm going to make two variables, one called intersection, one called date. But this time I'm going to have the input in front of what I want to print on the screen, which means I want the user to be able to type in the intersection and the date that we are looking for. So I will run this, and instead of the gray circle in the Jupyter browser base that we were looking at before, when you see spinning here, that's when the kernel is awaiting an input or it's calculating. So here I got the integer of 3, and we're going to enter 2021 12-09 in the standard ISO format for dates. Hit enter there. So now I've loaded intersection 3 in date is 21/12/09, and Colab is showing me what the values stored in these variables are right now. So now I'm going to use something in Python, which is awesome, which is called string concatenation. And I'm going to create a variable that I'm naming URL. And that URL is going to be a string in total, but I'm going to break it up. So I know from the call, from the documentation, that this is what it has to look like, and it wants to know what date. But here I'm going to use string concatenation to use a plus sign and go out to call it a string. This time I am going to declare, I want to make sure it's a string and it doesn't auto determine what my value is, and then go out and get the variable that's in date. Then go back and do intersection ID, go back to the variable intersection and insert it in here as a string as well. So I can run that. And here is the URL that's generated. So this is what's in the documentation of how the structure needs to be. Once again, you can just paste this in the browser. And I can see some stuff, intersection ID, I see trucks, lights, exits, daylight savings time. Okay, so it's a mess. So now I've got this string stored in a variable called URL. So now I want to create a new pandas data frame. And this time, instead of read Excel or read CSV, I'm going to read JSON and pass the parameter URL into that. So it's going to, this one will take a little bit longer. We loaded the data. Here, I'll take a slice for rows 0 to 4. And here's what we get. It's starting to get a little cleaner. The intersection ID is 3. Descriptions, Malden here in church. But now I still got in this traffic attribute column, I'm still seeing JavaScript notation in here with the curly brackets and the key value pairs. So I know I still need to flatten that. And you can flatten JSON by using the pandas JSON normalize. So I've got a column here called traffic. I want my data frame df to take on the values of JSON normalize. I want to flatten the JSON of data frame of the column traffic. So we have traffic here. So flatten this. So that ran. Let's take a slice of 0 to 15. So now we took all these timestamps, vehicle type. Now I've got it in more of a tabular form that we can kind of understand. So I've got some good information here, and like timestamp, look at midnight, vehicle type. Looks like this articulated truck right at midnight came through the intersection from the north. He went out in the south. There's actually 2 of them that the detection equipment counted, and it was not daylight savings time. So we've got some light trucks. It counts different versions here, articulated truck. But once again, there's a lot of rows here. And let's just see with shape. So my data frame is df.shape. So now I've got 6,400 rows. I have no idea if these are all of my different types of attributes. So that's where we can come back to the pandas unique. So data frame, and I want to see how many unique vehicles are in here. So that gives me back a list, and we see some new ones come up, right? Bus, bicycle, those were not in here at midnight. We didn't have buses and bicycles, so we would have missed those. So this gives me a good list. You could do things, users could type in bike instead of bicycle, and you'll need to change those to match up how you want, but at least you know that they exist. Look at timestamp for date type. So I still have a problem. It's listing it as an object. So like we did before with the mayors, I want to take the timestamp column that's in the data frame, and I want to have pandas use the method of toDateTime on my data frame's timestamp. So I want to convert this to the ISO standard date time. So we'll run that, take a look at the head, the first 3 lines, and I'm looking and I see that I've got some timestamps, but it's not showing any time. And that's just a quirk of pandas, that if it's midnight on the dot, 0000, it just doesn't display the time. So let's just get past, let's just go to 9, display the first 9 rows. As soon as you get past the 00s and it needs to display midnight plus 1 minute, it displays it. So that's just a weird quirk of it. But now we know we've got an ISO time, we've got what happened at that moment for each of these lines. This daylight savings time, I don't think we need it. So I'm going to now make my data frame equal what the operation output of this is here. So we're going to go with the dot drop method. In what column should we drop? It'll be daylight savings time. So here we have quantity, that's the number of vehicles. If I want to see the total vehicles for this time, I'm going to look at my data frame. I'm going to tell it, take the quantity column and use the .sum method. It's just going to add up every single one of those quantities. So for December 9th, at 27,840 vehicles passed through that intersection in some manner. If I want to see each of the types of vehicles, the numbers that they came by, this is where we can use pandas group by. And here I want to tell it, I want you to group by my vehicle types, articulated truck or bus, and then do the aggregation on the quantity column and sum all those up and then sort the answers in descending. So out of our 27,000 vehicles, 19,000 were light, 8,000 semi-trucks, transport trucks, buses, 154, and bikes, only 7 bikes out there. It seems low. You don't know if the equipment isn't picking them up, but also that intersection, kind of got to look at it, right? From like data analytics, like how many people are riding their bikes on here on Church right there, maybe crossing, but north-south could be lower than somewhere like around Riverside. So charting, coming back into our matplotlib library where the alias is PLT. This time I want to see, run this, I want to see the chart by vehicle. And here we're pretty much doing the same group by vehicle type, by how many that we saw per minute, and plot that in a bar chart. And then pyplot always ends with plot.show. I won't pass any parameters here, and I just get this chart here. So that's that. We can also look at, this is per minute. So every minute starting on the 9th at midnight, and here's 3 a.m., 6 a.m., 9, we can see like right around 6, the beginning of kind of a morning rush start to take off, peaking at 7-ish, midday lull, and then coming back home at 1700, and then back down again at 11:59. So we get to see the distribution. This is a line chart, but there's so much information that it kind of looks like a histogram, so it kind of works. You can also group by hour, and the key here was frequency is H, so that's by hour. You can change that to a bunch of different variables. We can go by 4 hours, and it'll break it down from midnight to 4 a.m., depending on what type of distribution that you're looking for based on your study. Actually, this was a 4-hour one too. And then lastly, you can make a list too for every single 4 hours. So from midnight to 4 a.m., I can make a list where it's summing up how many transport articulated trucks are coming through, how many light vehicles, single. You can kind of watch some trends. It's kind of weird that there's buses at 4 in the morning. So either they're tour buses. I don't think Transit Windsor opens till 7. So just weird. Bikes start to show up around 8. So daylight. And so we see kind of, you can map these out. You can chart these depending on what analysis you are using. But this is great to go from this structured data here to breaking it down to something that's more human readable. So I'll take the last, well, I'm at a minute, but we'll take the last couple current events. This one to show. This Blackburn news on September 11th, there was a traffic crash, right? So I'm going to, what I can do now, like say I'm going to be out of the office, I can just leave this notebook with my coworker. Just say, all you have to do is go runtime run all, and type intersection number in. It's 3. The date would be 2021-09-11. Once I enter that, it's going to continue. It'll iterate through all my code chunks. And what I'm looking for is this minute. There's a ton of information in here. We've almost got our normal distribution with, well, not normal statistically, but our normal daytime. It ramps up for morning rush. But then right here around 2:30, it just dives down and almost down to nothing, and then starts to creep back up around 5 o'clock, right? So the news article said that the crash occurred around 2:30. So we can look and say, here's 2:30, and it was closed, and they opened the southbound lane around 4, and they didn't open the northbound lane until about 7 p.m., about over here. So we can see these numbers just dive down. And so you could almost see the story without even looking at the newspaper article, that this is extremely irregular and an outlier. And you could go through and investigate, like, why did this happen? And you would find that Windsor Star article that there was a crash there. And then one thing, like, we've got to bring COVID into it, because why not? That's the story of the last 2 years. I'm going to do run all again. Remember that on the 9th, last Thursday, there was 27,000 vehicles at Malden and Huron Church. Premier Ford put a lockdown, our very, very first lockdown order, on March 23rd of 2020. So I just want to see, like, were people even listening or take it seriously, or like stop driving and actually stay in their house? So I can put in my March 23rd, 2020 at that intersection. When I hit enter, it'll go through all of the code chunks. We can even see here, like, 2020 is part of the JSON key value pairs. And then one key thing I want to show real quick too, table of contents, I put in sections. So now, like, say a manager or other teams are looking for this, they can just click on total traffic for the day. It'll go right to there as a bookmark. And on the very first day that Doug Ford made the lockdown order, we saw just 19,000 cars at that intersection. So down from 27,000 just a week ago. During that first lockdown, it was down significantly. You would obviously want to take like 7-day averages or look at average annual daily traffic. But for purposes of this, we did see a huge decrease just in that day. So those kind of things are interesting to look at. You can see, if I look at the 12th, it's a Sunday. So I'll run all again, intersection 3, 2021, 12-12. This time I just want to go straight to charting using my table of contents. And by minute on a Sunday, we don't see that morning rush peak at all. So even look at this chart, you can assume that this is a weekend when you start to see this. You can see accidents, you can see weekends and how they're different. So that's it. That's all I've got. Doug had mentioned that the code, the 2 Jupyter Notebooks, are in the Hackforge GitHub library. So those are accessible to anybody that wants to go out and give these a shot and see if you can add any other code ideas to it. I think one thing is the API is only really letting you get traffic per day, 1 day at a time. Normally on these URLs, you can put start date and end date, but no matter what, if you do that, it defaults to just yesterday. So you could use some type of loop, especially when you have these concatenated. You could loop this and just keep grabbing as many days as you want and then build it. And then once you get it, like Pandas has a 2 CSV or 2 XL, you could just export it out and have it and do it in a different platform or leave it in Excel. But I really encourage you to try these Jupyter Notebooks and see the power of being able to do it in code chunks and be able to reproduce this. Now, like any day you ask me a question, I can just go in and give you that traffic information for the day. So check it out.